So it's a 5-second pause. I know that the video might freeze, it might not. This one seems to be going. I don't know, it's applications week. So we're in our note sheet. This is the problem that I would like to do right now. A plane has an airspeed of 450 miles per hour on a bearing of 150 degrees. The wind is blowing from a bearing of 60 degrees at a velocity of 50 miles per hour. What is the true course and ground speed of the plane? All right. So here's what we're going to do. Okay. We're going to take these two different parts that we got going on, and we are going to utilize both of them. So the first thing that we're going to talk about is we're going to talk about the plane. Now, the plane has a airspeed of 450 miles an hour, and it's on a bearing of 150 degrees. So a bearing of 150 degrees has 0, then east is 90, south is 180, west is 270. So a bearing of 150 degrees is down that way. Okay? So that this angle right here is 150 degrees. Now that's great and all, and it's going at 450 miles per hour. Okay? Now, we need to bring trig back into play with that. Well, trig has 0 out here, 90 up top, 180 down below, 270 or 180 out to the left, and 270 down below. So if this is 150 degrees, that leaves me with 30 degrees in there. So this gives me a trig angle of 300 degrees. Okay? That's important because now what we're going to do is we're going to figure out the plane's vector, and we're going to call that A because that's what we're sending the plane out into the world with. Okay? So that vector is going to be, its magnitude is 450 times the cosine of my trig angle, 300 degrees, and 450 times the sine of my trig angle, 300 degrees. Okay? Now, when I do that, if I type that into a calculator, 450 times the cosine of 300 degrees gets me, and I am going to store that as my A. That's going to get me 225 for the horizontal component of my vector. And degrees, I'm going to store this as my B. That's going to give me negative 389.711. Now, let me switch back off of that. Okay, so if I think about this, okay, I'm in quadrant 4. I'm down here which means I should have a positive x value and a negative y value. Positive x, negative y. So it all works out, and it's all good. That's my aim of my vehicle, which in this case is a plane. Now, let's deal with our wind vector. So the wind vector says that the wind is blowing from a bearing of 60 degrees. So 0 is up top, 90, 180, and 270 because that's bearing. So I'd have a 60-degree angle in there. But the wind is blowing from that, which means that the wind is really blowing out that way. So if you get a red marker here, okay, so if that's 60, then this would be 30, which means that that would also be 30 in there. Okay. So now if I switch that over to trig, now this is 0, this is 90, this is 180. So my trig angle is going to be 210 degrees. 0, 90, 180, 30 more, trig value of 210 degrees. So now my wind vector has a magnitude of 50 miles per hour. Should write that down. Okay. So that's going to be 50 cosine of 210 degrees and 50 sine of 210 degrees. We can now go to a calculator for those two. 50, oops, there we go. 50 cosine of 210 degrees. I'm going to store it as C. Gets me negative 43.301 and 50 sine of 210 degrees, and I'm going to store that as D. Now, if you don't have the storage capabilities of on your calculator, you're just going to have to write those numbers down. Oops. And you just utilize them from there. Okay? So that gives me my wind vector of negative 43.301, comma, negative 25, which I'm in quadrant number 3, should be negative, 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 negative. Love it. Okay? So now my true flight of this plane is going to be from that formula A, my aim, plus my wind is going to equal my true vector. So my aim vector was 225, comma, negative 389.711. My wind vector was negative 43.301, comma, negative 25. Okay? And that's going to give me my true course and speed when I finally do that. So 225, so now I can go back to this one, and because I've got them stored on my calculator, I can go A plus, maybe I can, now I can go A plus C, and that gets me a vector of 181.699, comma, and then I can go B plus D, negative 414.711. One thing I didn't do is I forgot to store them as an X and a Y value. So I've done that here now. I've just stored them in same values, stored them in as X and Y, because what it's asking me to do is it is asking me to find the true course and the true ground speed. Well, the true ground speed is going to be the magnitude of this new vector. The true course, that's going to be the bearing angle of that new vector that we just came up with. Get my calculator back on here. And so what we need to do is we need to find the magnitude of g. That's going to give us our speed. Well, magnitude of a vector is going to be the x component, the horizontal component, squared, plus the y component, or the vertical component, squared, and then I take the square root of that. Okay, so back to the old calculator. So I'm going to take the square root of x squared plus y squared, and that is going to give me a magnitude, or a speed, of 452.769 miles per hour. Yeah. And that is my true speed. Yeah. Now I need to find the angle that this is going on. Well, that's going to give me a reference angle of the inverse tangent of the y value divided by the x value. I drop any and all negative signs, and that's going to give me a reference angle of, let me go back to the calculator here now. So I want the inverse tangent of, now my y value is negative, so I'm going to type it in as negative y divided by x, because I want to drop those negative signs. And that's going to give me that as an answer, but that's radians, because my calculator is in radians. So I need to multiply that by 180 and divide it by pi. So that gives me a reference angle here of 66.340 degrees. .340 degrees. Oops, looks like I need to, if that will help No, maybe if I adjust my lighting so we don't have that big of a... Ooh, look at that. It's kind of funky. How we can make that go up and go back and all that good stuff. Okay? I know Lindsay's getting a little cray-cray here. Getting a little stir-crazy. Okay? Okay? So, this vector is in quadrant number 4. It's got a positive horizontal component, negative vertical component, puts me in quadrant number 4. So that puts this as my reference angle there. Okay, ooh, that's bad. See if I can. I'm trying for you here. Nope, dropping magic sand over here. No, that's okay. You're good. Okay? I'm just trying to, maybe if I backlit it. Oh, nope, now we got a big old glare going on right there. That's right. We'll figure it out. Yeah. Hey, I'm learning. I know that's quite the oofda. Actually, here we'll do this because I know we're below that. We're below this glare. Okay. So my true theta then, here would be my bearing of 0. It would come down all the way to there. So this would be 90. So I'd have 90 plus, because I'm in quadrant 4 in my bearing. So my actual theta of G would be 156.340. Squeaky marker too. 156.340 degrees for the bearing angle of that plane. Okay? Hey, we're all working through this together. Okay? So what I want you to do for tonight is I want you to do the extra practice that is right below this page. So finish off page 2 of the notes packet. Have a great day.